Hey everyone, welcome back to the channel. In this video, we are going to talk about one of the core pillars of modern DevOps, infrastructure as code, also known as IaC. This concept completely transforms the way we manage infrastructure by making it automated, versioned, and secure. So, what exactly is infrastructure as code? The main idea behind IaC is simple. Instead of manually configuring servers, switches, and cloud resources, represent the entire infrastructure as code files. These files use high-level descriptive languages, and we store them in a source control system like GitHub or GitLab. Once the infrastructure is written as code, it can be handed over to automation tools such as Ansible or Terraform, which can deploy or destroy that environment on demand. Managing infrastructure as code instead of making one-off manual changes brings huge benefits that developers have enjoyed for years. First, version control. Every infrastructure change is tracked. You can perform peer reviews, require approvals, and even roll back to any previous version. Second, testing efficiency. When integrated into your CI/CD pipelines, your infrastructure changes can be tested automatically, usually first in a test environment before reaching production. That means safer deployments and faster delivery. Third, self-documentation. Your infrastructure literally documents itself. You can rebuild the entire environment anytime from the same code files, and your Git history tells you who changed what and when. And finally, single source of truth, as we call it SSOT, because all definitions live in source control. Your deployed infrastructure always matches the declared state. Now, IaC isn't just about servers or virtual machines. It's equally powerful in networking world. We call that network as code. You can define network configurations like interfaces, VLANs, or access lists in YAML or JSON files. Store them in Git, and use Ansible to push those configurations to devices automatically. Here's how it works step by step. First, you define your network configurations in YAML or JSON. Then you version it in GitLab or GitHub, so every change is tracked. Next, you create a CI/CD pipeline that automatically deploys changes. Before deployment, you test everything in a lab, maybe using Cisco Modeling Labs or CML, to ensure configuration accuracy. And finally, you deploy it to your production network with a single command. The result is a consistent network state, a complete change history, and pre-deployment validation, just like any other DevOps workflow. Of course, when you start managing your infrastructure as code, you need the right tools. The two most popular ones are Ansible and Terraform. Both can be used to manage Cisco devices, cloud resources, or even virtual labs, but they approach things differently. Ansible uses an imperative style. What does it mean? It tells the system what steps to take. It's agentless, uses YAML playbooks, and is great for configuration management and orchestration tasks. Terraform, on the other hand, is declarative. You describe the desired end state, and Terraform figures out how to get there. It manages state files, supports multiple cloud providers, and follows a plan and apply workflow. Cisco supports both tools across many platforms, So your choice depends on your environment and workflow. There is no single best tool. It's about what fits your automation style. In fact, most engineers use both together. For example, Terraform for provisioning infrastructure and Ansible for configuring it. So here are the key takeaways. First of all, treat your configuration files as code. Second, follow DevOps best practices, version control, peer review, CI/CD pipelines. And finally, choose your IaC tools based on your needs, not trends. And remember, infrastructure as code isn't just a tool set. It's a mindset that brings automation, consistency, and reliability into every layer of your infrastructure, including your network. So now let's switch to VS Code and do some stuff. Look at this simple example. We have one TF file, Terraform file, and we have two sections in it. Just for showing the sample, I put those parts in just one single file. In the section that shows variables.tf, here we are declaring a variable called instance type. The block looks like this. As you see, the variable keyword tells Terraform that we are defining a new variable. The name inside the quotes, in this case, instance underline type, is what we'll reference later in our configuration. The description is optional, but it's always a good idea to explain what the variable represents. The type here is a string, meaning this variable expects text, not numbers or lists. So pay attention that when we use the type as a string, we mean that the variable expects the text, not numbers or list or any other data types. And the default value is t2.micro. So if the user doesn't specify a custom instance type, Terraform will automatically use t2.micro as we see here as a default. And now let's switch to our main.tf file. Here we are defining two AWS EC2 instances, one called VM1 and the other VM2. Notice that both resources are using instance type var.instance type. This line tells Terraform to pull the value from our variable instead of hard coding it. That means if we ever want to change the instance type, for example, from t2.micro to t3.micro, we update it once in the variable file and both instances will use the new type automatically. Now, if we want to run, we run Terraform init and Terraform plan. Terraform reads the variable definition, substitute the default value, and shows us the two EC2 instances it's going to create. No errors, no undefined variables, everything works perfectly. So that's how you use variables in Terraform. You declare them once, reference them across multiple resources, and make your infrastructure code reusable, flexible, and much cleaner. Now, let's switch to another example. Here, we want to compare two pieces of network automation code, one in Terraform, using the Cisco iOS XE provider, and one in Ansible, using the Cisco.iOS collection. Let's go deep and explain both line by line and also show how they relate. First of all, let's review the Terraform configuration for Cisco iOS XE provider. Here, as you see, the line that tells resource Cisco IaC interface gigabit Ethernet 1 declares a Terraform managed network interface resource using Cisco IaC provider. And gigabit Ethernet 1 just the internal Terraform name, not the device's interface name. And after that, we have the name, the gigabit Ethernet 1. This is the actual interface name on the Cisco router. And after that, we have the primary IP address for the interface that we set, as you see. And after that, we have the subnet mask, and we have makes the IP address as a secondary address. On IaC, this is equivalent to IP address, the IP and the subnet mask that we want, and after that, the keyword secondary. Terraform's role here is as follows. Terraform connects to the IaC device via netconf or restconf, converts this HCL configuration into device commands or YAML models, and applies it declaratively, meaning Terraform ensures the interface always matches the desired state. And the same will be applied for gigabit Ethernet 2. Terraform's Cisco IaC provider ensures your network device configuration is always aligned with the code by doing three main things. First, plan compares current device config versus desired config. Second, apply pushes only the data via netconf or restconf. And finally, state management keeps a local .tf state file to remember what's been configured. And some points that we must remember, that is idempotent, safe to rerun, declarative, that we described the end state, and great for version controlled infrastructure. Now let's switch to the Ansible playbook. To be honest, this is just a snippet of the Ansible playbook, not the total, that we use Cisco iOS collections. You see the YAML code here. We have the name. This is just a human readable task name in Ansible. After that, we have the Ansible module used to configure layer 3 interfaces on Cisco iOS or IaC devices. After that, we have the keyword config. This is defining a list of interface configurations to apply. We have name, that is the interface's name on the router. After that, we have the IPv4 keyword that defines one or more IPv4 addresses for that interface. And after that, we have the IP address and prefix length. And by the keyword secondary and make it true as a Boolean, we make it as a secondary IP address. And the state, we mentioned it replaces the current device configuration for those interfaces with this one, as opposed to merging. As we see, Ansible executes tasks imperatively, step by step, via SSH or netconf. It logs into the router, pushes this specific configuration. If a state is going to be replaced, it removes any existing L3 configuration not listed in this task. We must pay attention that it doesn't maintain a state file like Terraform. It just enforces changes at runtime. It is task-driven, as we say, imperative. It is flexible and fast for procedural automation and ideal for configuration pushes, updates, and multi-device playbooks. So if you want to compare Terraform and Ansible side by side, for the approach, we can say that Terraform is declarative, what should exist, and Ansible is imperative, do this now. For the connection comparison, Terraform uses restconf or netconf, and Ansible uses SSH or netconf. We have a state file in Terraform, that is terraform.tf state, but in Ansible we don't have any state file. It is stateless. For idempotency, Terraform is strong via state tracking, and Ansible is moderate. Depends on the module logic. Terraform's use case is for persistent infrastructure provisioning, but Ansible can be used for configuration management and orchestration tasks. And the syntax in Terraform is HCL, HashiCorp language, and in Ansible we have Ansible playbooks that use YAML formats. In real network automation projects, you can actually combine both tools. Use Terraform to provision the device, define base interfaces, and create the desired state in code. And use Ansible afterward to perform configuration validation, backups, or push one-off operational changes. For example, Terraform builds the interface skeletons via RESTconf, and after that Ansible verifies the routing and applies ACLs via SSH. And as you see, we just review and compare the Ansible and Terraform that can be used as infrastructure as code tools. When you manage your infrastructure as code, it is important to choose the right tool for the job. There are many different tools available today, and each tool has different strengths. And the two of the most commonly used tools are Ansible and Terraform. Both tools can be used to achieve similar results, but they operate a bit differently. Cisco in general offers support for using both tools for managing different products. For example, both tools can be used to manage Cisco IaC devices. Ansible and Terraform can both be used to manage CML network simulations as well. And one approach is not inherently superior to the other. And the approach you use often depends on your specific needs. Also, the boundary for particular tools is not always strict. For example, Ansible uses modules to define the actions. Some modules are written in a way so that you describe the desired state. It is the responsibility of the module to check the current state, compare the current state with the desired state, and perform actions if needed. And it often depends on which tool you are more comfortable with to start managing the network. You also will frequently use a combination of tools to manage different aspects of the network. And the key is to treat configurations files like code and stick to good DevOps practice, no matter which tool you choose. If you found this helpful, don't forget to like the video and subscribe, because in the next session we'll actually build an IaC workflow with Terraform and Ansible in action. Thanks for watching, and see you in the next video.